Okay, so today's topic is momentum, and we're just going to go through starting with the definition. Okay, so momentum refers to the quantity of motion that an object possesses, or you'll sometimes see that definition shortened to just the words mass in motion, which when we look at the formula in just a moment will make sense because that equation is going to take into account the amount of mass the object has and the quantity of its motion. It's a term that you'll hear a lot in sports, and it's always describing the movement of an object, or you'll hear it a lot of times like the momentum. The team has all the momentum because they just, had an interception, and you're talking about football, or a home run if you're talking about baseball, but they'll talk about teams having momentum. And it usually has to do with motion, moving forward. And so again, the definition, quantity of motion that an object possesses, or mass in motion. By the way, these notes, this slideshow is available to you in both MyOpenMath and in Schoology if you do want to follow along. Or if I happen to go too fast, you're welcome to open that back up later to catch up with any pieces that you missed. So when we say mass in motion, we need to identify what we mean by motion. We've talked about different types of motion last semester. We talked about constant velocity, and we talked about accelerated motion. And so we can obviously talk about momentum in terms of these different types of motions, but for today, our discussions regarding the momentum of an object, we're only going to be looking at constant velocity, which means we're going to be dealing with objects that have a constant momentum. There will be a point later on where we do look at accelerated motion, and then we'll be talking about objects with a changing momentum, but for today, everything we're dealing with will be constant velocity and therefore constant momentum. Momentum is a vector. As a reminder, those vector quantities mean that they have both magnitude and direction. So whenever you specify the momentum of an object, you'll need both a number value and the direction of that momentum. When we look at the two different variables that affect the momentum of an object, we have mass and we have velocity. Mass is scalar, it has no direction, but because velocity is a vector, so is your momentum, and because velocity is that vector quantity with direction, the direction of your momentum will be in the same direction as the object's velocity. Okay, so if an object is moving forward with a certain amount of velocity, it will also have a forward momentum. That's what that last point says. Momentum gets its direction from the velocity of the object. So again, vector quantity means that you need to pay attention to what your positive direction is. Whenever you start doing calculations, you'll need to pay attention to that so that you have identified your direction and have the appropriate sign for your momentum, or that you're using the appropriate signs as you solve for it. For this unit, we will discuss linear momentum. So we're going to be dealing with things in a straight line, and we'll restrict our discussions to the motions of objects in one dimension. There will be a point where we talk about angular momentum later on, but again, in this unit, we're going to deal with one-dimensional linear momentum. The symbol for momentum, whenever we start looking at the equations, or if you have your AP Physics 1 formula chart out and you're looking for it, is a lowercase p. So the variable you're looking for is a lowercase p. Obviously, m is already taken, it's mass, but the p comes from the Latin patere, meaning to go or to move towards. Again, if you think about the definition, that moving forward motion, that momentum is where that word came from and how they got that symbol. So again, lowercase p. Sometimes students will mix it up because you're going to see m in the equation. Please make sure you remember that that m, that lowercase m is mass, the lowercase p is the momentum. Here is that formula I was referring to, P equals m times v. Again, the definition gives us a clue to the equation. Since the definition for momentum was mass in motion, our equation, again, it has mass and it has motion, mass times velocity. The units are going to be your units of mass, kilograms, multiplied by your units of velocity, meters per second. So our unit for momentum is the kilogram meter per second. Okay, and so we're going to use this equation in just a moment to try some example calculations, but it's a 3-variable equation. That's why I said the notes today are going to be pretty straightforward, because this is one of the easiest formulas you're going to see. Of course, we're going to make it harder, but for now, for today. All right, so here is an example problem. It says a 26 kilogram dog runs along a straight path at a constant -5 meters per second. What is the dog's momentum? Again, when you look at this situation, this problem, you're going to want to identify the information you have. We have mass, we have velocity, and so we can solve for momentum using our equation P equals m times v, and it's a simple substitution. 26 times -5 will give us a momentum of -130 kilogram meters per second. As I said, probably the easiest problem we've done all year, okay, or one of them for sure. So again, pretty straightforward when all we're doing is calculating momentum when we have an object at constant velocity. Okay, so mass times velocity in this case. Notice the sign, -130 kilogram meters per second. Our momentum is in the negative direction. It will be in the same direction as the velocity. Questions about this? Okay, making sure. Let's try this one. A 60 kilogram biker is traveling at 8 meters per second. How fast would a 24 kilogram kid need to run in order to travel with the same momentum? Okay, so again, now we have two different objects and we're just doing a comparison here, but if we want to make the kid have the same momentum, we need to know how much momentum the biker has. So I can set them equal to each other. I have enough information to determine the momentum of the biker because I know the biker's mass is 60 kilograms and the biker's velocity is 8 meters per second. Therefore, I can find the biker's momentum and I can set it equal to the momentum of the kid, keeping in mind that the kid has a mass of 24 kilograms. So if I were to set these equal to each other, the mass of the biker times the velocity of the biker should equal the mass of the kid times the velocity of the kid, since we're looking for the conditions required for the same momentum. Okay, plugging in. That's 60 times 8 equals 24 times velocity of the kid, the unknown velocity that we're solving for. We just need to multiply those, that's 480, and then divide both sides by 24. And we find that the kid would have to travel at a rate of 20 meters per second in order to have the same momentum as the biker, which is way too fast for someone to run. But I guess if he was in a vehicle. All right, again, questions about this? As I said, we're at least starting off with some easy stuff. Okay, I know it's real quick because, as I said, the notes are quick today, and you have the entire rest of the period to work on playlist 1. Playlist 1, again, the task option, you're going to find that in My Open Math. You will also find the checkpoint in there, but it's due tomorrow. If you have questions as you're working, let me know, and you are more than welcome to work with a neighbor.